Let's continue. Let's continue. Welcome back. Welcome back. Welcome back. Yeah. Don't forget to subscribe, comment, like, and share. Yeah. Thank you. Those who have been following. So of which I'm going to jump to question 9A up to F, because this you can solve. I've already solved. Yeah, I can just get someone idea, but just like so more like the same question by changing of the numbers. Yes. So I've got this one G, n squared, which is greater than n plus 1. And also, if you see there's a condition that have been given, n should be greater than or equal to 1. Also, should involve step 1, which is let n, that's an assumption. Now, in fact, you're going to create an assumption following the condition that have been provided. In this case, the condition that have been provided, n should be greater than or equal to 2. So, for instance, let's say equal to 2. So, if you get 2, what's going to happen? There we go. Here we go. So we say, we got the same thing, the same equation, n squared, which is greater than n plus 1. Whatever is n, I'll be putting 2 greater than 2 plus 1. What is 2 squared? That is 4 greater than this plus this one, that is 3. And 4 is greater than 3, yes. Of which you can say, therefore, it is true and it should be greater than or equal to 2. Then let's go to step 2. You say let n is equal to k. Note that step 2 is the purpose of step 3. So you say, you get the same thing, you say n squared is equal to, or n squared greater than n plus 1. Whatever is n, put k, then put k plus 1. Yes. At this stage, you can mark this one as x, because that's the purpose of it in step 3. You're going to use it in step 3. So go ahead, you say step 2, 3. Say let n is equal to k plus 1. Then get the same equation, say k, whatever it is, and then get the same equation, you say n squared greater than n plus 1. Whatever is n, put what? K plus 1. Squared there on top. Greater than whatever is n, put k plus what? 1. Right? Plus 1. Of which to be k squared here. If you have to, because same applies to turn into quadratic equation, same applies. This same applies to k plus 1, which is greater than k plus what? Plus 2. Now, if you see very much properly, this one same applies with k plus 1 squared, which is greater than k plus 2. If you want, you can end it here, right? Now, can you try to prove, if you want, you can end it here. Can you try to prove also to find out if proving will result into this? If you say k squared plus 2k plus 1, which is greater than, now watch out. If I had to go back to step 2, this is k squared, which is this k squared, right? So this is k squared, this is this k squared, right? Of which same applies, I've only added 2k plus 1. So what's going to happen? So even this side are going to maintain the same thing. You say k plus 1, k squared, which is k squared, k plus 1 is k plus 1, which is showing to say it's only an addition of 2k plus 1. So if I say 2k plus 1, right? So what's going to happen is this one I turn it, or I bring it back the way it was, then greater than, then I maintain this one, the original one, plus the addition one, whereas k I put the condition that has been provided, which is what? Which is 2. Which one, right? So whereas k I put what? 2 plus 1. Then I say k plus 1 squared, which is less than k plus 1, plus, this time this one, that is 4, plus 1. Of which it is k squared greater than, if you add everything here to be k plus what? 6. Right? If you keep on reducing this one by 2, the way I said is divisible. So keep on dividing by 2. Using the 2 that have been provided, I'm going to find the same k plus 1 squared step by step, or subtracted by 2, we remain with 4. K plus 1 squared subtracted by 2, we remain with 2. Of which this and this, it's one and the same. At this case, we can say, therefore, it is true n is equal to k plus 1. Hence, it is true n is a member of what? All natural numbers. Thank you very much. This is Elias Sinkala. Please try to comment, like, share, and also subscribe. And also punch on that this notification button. Thank you very much. Stay blessed.